Hello.
Hey,
Hi. Hi, chat. Chat, is it okay if I call you chat?
that's the
It's like,
what? What are they? What someone described it as the first fourth person pronoun chat,
oh,
and then a bunch of linguists
wow.
sort of swooped in. They're like, "That's not what that is." But like, yeah, the idea of like the sort of cosmic. It's almost like a Greek chorus, right?
Yeah.
All right.
Um, yeah, for people tuning in, Andy is not with us today. He's vacationing in Japan, excitingly. This was scheduled for last week, but because of the way that the world is, it couldn't happen. So
Yeah.
here we are. We're going to talk about cooperative routines instead of
Yes.
cooperative economics. I've made this
Yeah.
joke like 3 times already in like
It's
various chats and posts, but
it's so good. The branding writes
it's
itself.
right there. It's right there.
Worker
Uh,
cooperative routines. It's just the future.
yeah, we're ready for it. Um, cool. I've got our screen share up, so we're ready to start whenever you are, Ramsey.
To get into it. Yeah. So I'm really excited to do this. Anyone who knows me or like follows me on Mastodon knows that coroutines are kind of all I talk about when it comes to game architecture and software architecture. Um, but they really are incredible. I feel like maybe ever since grad school, I have been looking for a set of programming language semantics that would make me feel expressive while while making games and interactive software and the other kind of stuff that I make, that Emma makes. And I spent, I think, like a decade in like functional programming and Lisp and like doing all kinds of stuff, all of which was well spent. None of it was a waste of time. But the thing I came away with was like, oh, coroutines are actually magical. Like this is kind of what I've been looking for. So um, and I'm excited to share them with you, Gwen. You've been using them in you've been using the system in a game that we're making at Emma for the Arcade Commons in Brooklyn.
Yeah,
Um,
our limited release arcade game.
yeah, yeah. You have to come down to one specific bar in Brooklyn to play.
Very limited.
Uh,
But yeah, no, I've been using it. The coroutine stuff is cool, and this implementation is cool. I've obviously used coroutines a lot for other things. I use them in Unity all the time. Um, I used them a fair chunk in the last 2 projects I was working on in the captioning tool and the like interactive map archive thing. Both of those had at least a non-trivial amount of coroutines, but I did use them a little differently. I was had them rather than having a like global tick, it was like these fire when events happen, right? When like
right.
JavaScript event loops happen. Um,
Yeah.
which for me, I don't know, like for a lot of stuff kind of makes more sense, but yeah, it's kind of just 2 ways to do it. But yeah, I'm
Yeah.
excited to get in the details of Ajeeb.
Yeah. So they're definitely inspired by what you have in Unity. You can do coroutines in Lua in the same way that like you have like different programming languages have like functions and closures, but like the specifics are a little different. Um, Ajeeb is it's a sort of broader set of tools that I use to like make games, and this is an implementation of coroutines that I have in JavaScript that I'll be walking you through. Um, a lot of it will overlap with like Unity and Lua stuff, but there's some. I think the main my not to sort of ramble too much about theory before getting into some code. Um, I think the main difference, the thing that has me excited, is that something you don't do in Unity is I think that you can really use coroutines to be the central or the load bearing abstraction for your entire system. Whereas in Unity, it's game objects and components. It's this kind of messy entity component system. And then off to the side, you have coroutines to do like animations and stuff. Um, I've almost come to like the kind of reverse conclusion where like actually the fundamental abstraction that I want is the coroutine. And then if I need an entity component system, I could put that on top of it or whatever.
Right.
Um, and so that's some like towards the end, there are some like interesting sort of branching, semantic stuff we could look at. But to dive into the code, what we're looking at is almost something that was produces a side effect of getting this skill tree together. This is a coroutine explainer tool. It's not specifically just for coroutines. It's kind of a JavaScript control flow analyzer. It's like maybe one way you could think about it. It's inspired by some of Brett Victor's writings from like 12 years ago. But it's got a bunch of sort of built-in examples. We're gonna work through them. I'll move through the first and like with some speed, just because it's gonna be pretty straightforward, and try and spend a little bit more time on the ones towards the end.
Oh, sorry, is this not the one that's live at coroutines.cool?
Oh no, it's not. So
oh, sorry. One sec.
This
Chat, I'm sorry, I sent you the wrong link. I'll send the correct one.
So this may be, I still haven't decided. The problem with coroutines.cool is it's such a cool domain name. I'm like almost paralyzed with like, what do I do with it?
Yeah, you've got classic new sketchbook paralysis. Like, no, this is a beautiful new item. I can't destroy it.
I can't. I owe future generations like, stewardship of coroutines.cool. I think I want coroutines.cool to be like a shader toy for coroutines. And I do think this tool might be the basis of it. But we will see where we get where I get to with that. But yeah, no, it's just hosted on my own static site, my own static site server. So let me know when you get that.
Yeah,
link
out. No, you can go ahead. I'm typing the link. I'm sure they can see it in the video.
So this is fun because it's live, and you can follow along, and all the code is editable, and you could like hack on it and sort of ask it questions and get reactions. The first two examples just kind of explain the interface. So if you hit play or hit Alt Enter, what happens is the code that's in the editor will run to completion, and we record every step of execution. And you can scrub through the steps of execution with the scrubber here. And you'll see 3 lines highlighted. The yellow line is the current line of execution. So here I've scrubbed to step 3. So the third expression, or the fourth, right? Because 0 is the first, is the one that's highlighted. The red line is always the previous expression, and then the green line is always the next expression.
Okay, yeah, I did not know what the colors meant.
Yeah, this is something I've like went back and forth on, and the basic idea is to think of it like a stoplight, right? Where it's like red, yellow, green, and yellow is always the current one, green is the next, and red is the previous. The idea is that like as control flow gets more interesting, having a sense of where we came from and where we're going to is helpful. For any line, for any expression, really, it's not just based on lines, it's based on expressions. For any expression that modifies a value, the resulting value is visualized in like to the right. So here we have other number starts off as 10. We set it to number times 2, so it's now 24. We subtract 20 from it, so it's now 4. We add 1 to it, so it's now 5. So 4 plus 1 is 5. So that this little gray number off to the side is the sort of resulting value.
Right.
A lot of this stuff hinges on like mutating state. So like being able to track state and like, the values that are in variables is quite important. It is it wraps all of JavaScript. So you get things like loops would work the way you expect. So we sort of stay in the loop until we get out. For loops also work. So this is an example of how it's not just based on lines, but individual expressions. So the first bit of the for loop, that evaluates first, and then the second bit of the for loop. Again, we stay in the loop until we get out. A nice little shortcut that I added pretty recently is if you click on a line, it'll run forward to the next expression that starts on that line. So if you're in the middle of a long loop, you can just kind of click and you sort of jump forward.
Just jump out of the loop. It's that thing in the stepping debugger I never really understand.
This is also like very much inspired by stepping debuggers. For the longest time, I felt like in order to like really understand a coroutine, just like use a stepping debugger. Like no one wants to use a stepping debugger.
Very, they're like a quietly very divisive technology. Like some people love them, some people hate them. Everybody feels that they are absolutely correct.
Yeah.
I never use them. I don't know if that makes me good or bad. I don't know which side I'm on, but definitely not Stepping Debugger's side.
Yeah, I don't know. For when I've needed them, I've like needed them.
Yeah,
But
I've just always found that like technologically they don't work. Like GDB
oh god, no,
doesn't
yeah.
work very good for me. Unity's debugger, God help me, even worse. And like those are the only two times I've ever wanted one. Like
There's one built into the browser. It's really good because the browser is an acceptable small talk.
yeah.
But this is also fully time traveling. So you'll see that there's a console, this little gray area over here. If I scrub back, I rewind the console and scrub forward. I like play out the console. So we have a kind of a full sort of snapshotted sense of the world. And it is the full language to the best of my like understanding. Function calls and everything should kind of work.
Right.
So that is the basics of the interface. The next example is basically the same, except it reveals the time traveling canvas. So much like the previous example, this one is now loading Pixie.js. This is stock Pixie 7, nothing special, nothing fancy. Some of the examples use images that I do load out of a module. This module isn't special either. It just like preloads the assets. While I was putting these demos together, I ran into an issue where I didn't want to like make all my examples like async await because then it gets really, really noisy, and I'm trying to keep them super short. But I also didn't want like the first like 3 frames of coroutines to run and like everything is black because the images haven't loaded yet. So that's like really confusing. So this module just preloads the assets. It's nothing special though.
Yeah, no, that makes sense.
It's just like the images are there. But so this is all otherwise idiomatic Pixie code with request animation frame. And so we create a little card sprite and then we rotate it every frame. And as we scrub back and forth, we'll see we set up the sprite. For things that are objects, we get this little hash kind of notation just because there isn't really a good way to print them out. We give it values for X and Y, we enter the loop, and we see, even when we start doing math, the funny results of our dividing by 20 and adding to rotation. The $sign frame function basically just takes a screenshot. And like we'll see, like as the screenshots accumulate, that's where they show up. The first one never shows up, and I think that might be a Pixie timing thing. But as we go in, we'll see that we increase the rotation. There's the card, and we'll see that it rotates slowly.
Yeah.
Right, we go back and forward. This is a expression counter, and then this is a frame counter, right? So it's 13 out of 20 frames, 64 out of 91 expressions. The one other thing is this will run forever. So all of my examples have logic that bails out of the request animation frame. If you're making a game, you would never actually do this because you just want your game to kind of run forever. But all the examples basically like the animation runs up to a certain point and then purposely quits just so that we don't take screenshots, because these are screenshots.
Right.
Which are just basically like DDoS, the browser.
Yeah.
How's that interface wise? Does that kind of make sense? Like how it's working?
Yeah, that makes sense. Is this like boilerplate code? Sorry, I haven't looked at the examples, but is that boilerplate code in every example?
Yes.
Or is this like the secret backend?
Hold on. What do you mean? The Pixie?
Like, is this code literally in every single, or something like it in every single example on the page?
Yeah. Okay. Every example is built from scratch on purpose.
Got it. Okay.
Nothing up my sleeve. Yeah, it's just completely. I was also even really hesitant to do this like assets thing, but it's kind of unavoidable.
Yeah, I mean, I think that makes sense. It's just no, I was wondering whether this was like, whether the pixie was like a thing that you're supposed to look at when you're looking at this tool.
Yeah, no, it's going to be in every single one.
Gotcha.
So yeah, you could jump into any one basically and start reading. So we're going to move right into coroutines, or the sort of building blocks of coroutines next. And the next example takes this simple example, which is basically an update loop that modifies the rotation of the sprite every frame. And we're going to sort of rewrite this on top of a generator. So very similar in that we have, I'll run it so we see that the result is basically the same. It's similar in that we have a sprite. We give it an X and Y position. We increase its rotation. But now it's wrapped in this like function star function. It's assigned to this variable, and we're calling this like next method. There's this yield keyword. So there's some differences, but it's broadly doing the exact same thing as the previous one, which is just an event loop updating the rotation of the sprite. So if we walk through the execution, we'll see, to your earlier question, Gwen, yep, we load Pixie, we set up the canvas. Nothing sort of repeated or hidden. We sort of evaluate these 2 lines of code, and then we come to line 20. We assign the result of calling this function star to R. And we'll see that the editor tells us that it's of type generator. Function star is what JavaScript calls a generator function. So that's the first like little bit of syntax that my system builds on. This is just like a JavaScript thing. Now, if we go into our tick, we'll see that the next line, we're about to call the tick function. The next line, the next expression that gets executed is on line 8. So we go into tick. We actually, this is a little hard to visualize, but the first thing the tick does is it calls next on R.
Right.
So next is 1/2 of the sort of the building blocks that the whole coroutine system rests on.
Yeah.
Next is how you enter a coroutine, and that takes us to the beginning of this rotate function. We go through, as in the previous example, we like evaluate these expressions. We come in here, we have this like this frames variable that's local. We modify the rotation, and then we hit yield. And then the next line after yield is line 23. And the value assigned to result is this object with a property done whose value is false. And then we check that, and then we make this sort of similar decision to like quit or not. So before even moving on, I just want to unpack those like components.
Yeah.
We have these function stars. They give us these like tangible objects that we can sort of carry around, right? In this case, R. On these like objects, we can call next on them. And from within those objects, we can call yield. So the way to read, they're called generators because JavaScript sort of implemented them for like other purposes to like generate sequences of values, but I'm only going to interpret them for like our purposes, which is coroutines, so control flow. And the way I read yield and next, there are these pairs of syntax where yield basically pauses the coroutine. So when a coroutine gets to yield, so if I jump down to here, we'll see that the next line executed after 17 isn't 15, which is what we would expect with a normal while loop. It's actually 23. We just get out of the coroutine, and then we just move on with the rest of the code. But when we come back, when we call next again, we don't jump to the beginning of rotate, right? Next initially kind of looks like a function call because it like just goes to the start of this rotate function. But when we call it again, it actually picks up at the while loop because next will resume a coroutine from wherever it paused itself at the last yield.
Yeah.
So
And
yield is like,
and that's visible with these like with the color highlighting on the lines.
yeah. The one, just because of the way JavaScript works, it like skips past the actual function invocation. It goes right into the function. Yeah. But so
optimized past it or something, but
yeah. There may have been a way to sort of wrap the code to prevent that from happening, but it was just like things were breaking. But basically the next line of code after line 27 is not 23, which you'd expect from a request animation loop. We'll just go right back into the while loop on line 15. And what's amazing about so that alone is interesting, right? So now we have functions that can basically pause themselves and they can be resumed from the outside. So there's a sort of relationship between being inside of a coroutine and outside of a coroutine, where the coroutine can decide to pause itself and something on the outside can decide to resume it. And so now you have these functions that can sort of break themselves up over time, where I'm like, I'm pause, I run a little, I get resumed, I run a little, I pause, and so on. That alone is powerful and interesting. But the real power and what a lot of like my like systems and the code that I built on top of them build on is the fact that all of the local variables are preserved across pauses. So the sprite in this case and the frame count are not like global variables, right? They exist only within this coroutine. It's all of the local. And when we go back to subtract from frames, we are subtracting from, if it was 20 in the last pause, it'll be 19 in this one, and then 18, and so on. So that is the key sort of ground level like bit of magic that has to kind of be built into the programming language. That's why you can't really add coroutines to just whatever language you want if the language doesn't have it built in. You need functions that can pause themselves, that can be resumed from the outside, and that have all of their local variables preserved and recreated basically across pause resume boundaries. That means that like architecturally, in situations like in Unity, where you're very often forced to like put something in a public field, right? Because you need to be visible in like more than one place or across frames. You have to sort of play these scope games where in coroutines you can really just use like function scope basically to like trap little bits of logic.
Yeah, that part is so nice. It's so nice to just not think about it.
Yeah,
like because yeah, you're right. The minute you're in any like object oriented context, especially in something as gnarly and twisted as video game, it's like, oh well, yeah, this would have been cool to do that, but here's a bunch of public fields.
Please don't write them or like
fuck them up.
Read them from a weird place that because this might change or whatever.
Just don't do that.
You have a language level guarantee that this sprite variable is not accessible anywhere except for.
Notably, you have like a language level guarantee, but you don't have the like encumbrance of like writing getters and setters or managing that scope or thinking about that or like making sure that it is accessible where you need it and not where you don't. Like that, at least for me, I've always found to be much more intuitive in a coroutine because it's like it's just a function. You just think about it like that and it kind of works.
No, you're totally right. So much of this is notational. Like you can do all of this. Actually, if you look at a C# disassembly of yield return, as the cool kids do, as one often does, they compile into classes with fields. Like it's kind of how you do it. But the fact that you can just write it with no ceremony, the fact that you can like nest them, as we'll see in like future examples, gives you a direct mapping of the lines of your code to time and to like the experience that people are having. that I've just never got from like object-oriented programming.
Yeah.
So it's kind of like, this is just in modern JavaScript, right? Yield, next. Those are the two. There are other things that they do that we're not even getting into. But
yeah, so you mentioned the generators are more for generating sequences. Is this one of those scenarios where they like sort of walk their way backwards into making coroutines, or did they go in with the intention of making coroutines a la Lua?
they went in. You can use generators. And for of syntax in JavaScript, you can feed it a generator, and then it'll basically call next on the generator to keep producing values. I'm actually in my my browser rewrite of 8th Floor, my live coding tool, is all based on like actually using generators as generators to generate sequences of notes. These are also the underpinnings of async await, is my understanding. They share a lot of infrastructure. So like async await.
That is a thing I do. I've used like async await, like coroutines almost sometimes. Like I think about them the same way.
They're very similar, and the reason so I don't use async await for a reason, which we see in example 3, which is like starting to. This is the first example that actually uses like bits of my system. So this is yield and next is great, but in general, even this is a bit clumsy. Like I don't want to be creating a bunch of like objects all over the place and remembering to call next on them and throwing them out when they're done. So all my system is, and it's of course it's open source, it's public domain, you can go read it. I think it's about 50 lines of code. There's like basically nothing to it. The main thing that it provides is a schedule. And the schedule you can pass. This is basically the same rotate coroutine as the previous example. The schedule is something you can pass coroutines to. And the schedule you can call tick on the schedule, and tick will run through every scheduled coroutine, call next on them, advance them to their next yield. If the coroutine is done, basically if it reaches the bottom of the function, it removes it from the schedule. That's all that's happening. Yeah. And it's doing that in a way that is the fastest way that I know how to do it. But it's not more clever than that. So it gives you this really nice syntax where you just say, schedule this, schedule that, and now they're all running in parallel, quote unquote. So if we run this, we see that we get these 3 cards, because each rotate now basically picks a random card just to make them visually distinct. It picks a random X and Y. Okay. And then it just runs through. So now if we'll see that for every frame, we should go into the while loop 3 times, 1 for each card.
So, does schedule run up to the first yield instantly, or does it wait for a tick?
It waits for a tick.
Okay.
And importantly, if you add in the middle of a frame, so if you call schedule tick, you're advancing all scheduled coroutines. If one of those coroutines schedules a coroutine, that doesn't run until the next tick.
Oh, interesting. Yeah, this is fiddly. That's like not the way I would expect it to work. I would almost expect it to run up to the first yield, but this might be the Lua-ism in my brain, because I think coroutine.wrap in Lua runs to the first yield.
Yeah. So
I think it does. Don't quote me on that, but I think it does something like that. Or maybe I just manually do it every time. I don't know.
All these systems are basically doing the same things, but they all differ in these little details. In Ajeeb, all the choices are basically born out of the experience of like using this at scale. And at every opportunity, the trade-off that I make is for determinism over anything else.
Makes sense. Yeah.
So for the systems that I build, don't ever want like when something happens to be a function of like where the generating coroutine happened to be in the schedule, right?
Yeah, we can't abide a race condition.
No, this is one. Like totally,
the
totally.
whole point, the whole like theoretical point of coroutines is not to have race conditions.
I use this system, actually, like a less optimized version of this system for the museum install in Philadelphia.
Right.
And this ran in a room with 32 projectors, and it was so deterministic that on boot, we'd see the first frame of like the projectors would like come up, and the first frame of like the graphics would come up on the same like integer number frame, plus or minus 2 or 3, because of like garbage collection jitter. But it's like, oh, it's frame 1012. That's when we see this image pop up. It's like consistently. That's what I want.
That's really impressive. That's like Unity can't do that. Open Framework can't do that.
Neither can async await.
Can't do that.
When you say async, when you say await, like, oh, when does that promise resolve? Eventually. Like, that's the formal answer, right? Eventually. Yep. And I want to be able to know, like, oh, my coroutines run when on line 34. Like, there's no ambiguity about it. They all run to completion there. Yeah. So it's super, super deterministic. And it makes performance trade-offs for determinism. Like, there are some performance hits that the system takes in the name of determinism.
Yeah, but we're making video games.
Like, yeah. We're
making a video game in a browser. We're not building AAA games. We are not Activision. We have opinions about Activision.
God forbid. Yeah, if we get there, we'd actually have to dissolve Emma.
Yeah.
But so we see when we enter a schedule, when we tick the schedule, we should do the while loop 3 times. So
yeah,
here's 1, 2, 3. So we did the 3 different 1, 2, 3, and then they all rotate a little bit. And then
I would love this. You do not have to implement this, but I would love something in this that would tell me what coroutine I'm inside of, which is non-trivial because like these are anonymous.
Yeah,
they're not anonymous functions, but they are like not. These are not named in any way.
Yeah, the instances.
So
harder.
It would be tricky.
What you can do in a stepping debugger, and it'd be a little harder to do in this, is when I'm in one of these zones, I could like highlight over one of these, and it would tell me like what actual value it is. Yeah. In mine, I could tell you the value. Even here, they sort of, because they're these objects, they don't really print out in a way that's super, super helpful.
Yeah.
Some of the later examples, I think, are a little bit more differentiated, so they're easier to tell apart. But yeah, that's the double-edged sword of like these like anonymous-ish dynamic functions. Is they're a little hard to even talk about and look at because they're all like unnamed.
Yeah, sure.
But and in case it wasn't like obvious, this is all not live codable, but you can edit this, and everything will reset. And if you rerun it, now I just have all these cards, right?
Yeah, absolutely.
So that's the first real the bit of infrastructure that my system offers. Every system has some kind of scheduler. Unity has a coroutine scheduler in the background that you don't really have access to.
Scheduler.
Yeah. Who knows what they're doing?
It's update in a trench coat.
God, that whole company is an update loop in a trench coat.
And it's different for every game. It's tied to a game object.
Oh, yeah, that's right. Mm-hmm. But that's the thing. It's like, your entity component system has primacy, right? That's actually the core semantics.
Yeah.
But mine is like,
Yeah, no.
So when I've built games with entity component systems, one of my coroutines would have an entity component system inside of it, and we just tick it. And then it's easy to put that inside of a menu system, inside of like a bigger kind of like application state.
Right, inside of a greater state machine. And I mean, that is the other thing that I like in games I use this the most for is like state machines. Every game developer's favorite thing to say and least favorite thing to do correctly.
I have not found a better notation for state machines.
No, me either. This is the best. I've written, the thing that comes to mind is writing boss fights in arcade games, where it's like you start off and the boss has this much health, and then you get halfway through and the boss's behavior changes.
Right. Yes.
Yeah, this is there was a boss I wrote for Swing Striker that was like, no, you're gonna fight it out for a while, and then its behavior changes. I'm like, oh, this is like 5 coroutines. Like you do the startup thing, and then it's like, okay, mode 1 has its little coroutine. Once the health gets so low, we pop back out, we jump into mode 2. Everything's a little different now. It's super clear and separate. Like, and I knocked the whole thing out in like half the time that it would have taken any other way. Like, that was choice 1. That was very satisfying.
And there's a mapping of your code to, like, on a line by line basis to time.
Yeah.
It's like, I know if I'm on this line, what has happened and what hasn't happened, right?
In a way what has happened and what hasn't.
Yeah.
And like, and there's also this other extra state of like boss health, right? It's like, I know what's happening over time, and I know where that boss health is at any given moment. Like, I don't have to like track those separately.
Yeah, totally. No, it's and I feel like a lot of interactive systems are either simulations, which, yeah, an entity component system or something is good for that, or state machines. And like, this is kind of what you want for a state machine.
Yeah. And the other trick is that like a lot of people will like talk about state machine and what they want is a slideshow, right? I've run into this one a lot where someone will say state machine, and what they mean is 10 things that happen in order.
Yeah, exactly.
But they want to be able to jump from 1 to 5 for no reason. It's like,
it's almost a linear.
Yeah. You lost it. And coroutines don't make that easier. That's client management. But there are ways, I mean, like this, and if you architecture coroutine carefully, you can kind of start to achieve that.
So the next sort of foundational bit is yield star, which is another language element. This is not a part of my system. But yield star is almost like, in the way that functions can call functions, coroutines can sort of delegate to other coroutines. So here, this graphical effect has the card fading in, spinning, and then fading out. The kind of thing you do, not an unusual thing to do in a game or an interactive graphical system. And the way we write it, there's actually just one coroutine scheduled, which is spin card. It sets up the sprite, again, as a local variable, initializes alpha to 0. And now this is the kind of code that I want to write. We fade the sprite to 1. We rotate the sprite. We fade the sprite to 0. This is about as close to like me saying like what I want it to be as possible. And then when we get to this fade, we do enter that immediately, right? So that basically gets treated like a function call. We compute the original alpha. We do this kind of lerp code that we've all written 10,000 times at this point. While t is less than, we set up t to be 0 while it's less than 1. We just lerp the alpha from its original alpha up to the target, which is 2. In this case, we passed in 1. And then we increment it by speed. When I'm building a bigger thing, I'll have an input system with like time and like an actual delta time. Speed here is just a stand-in for like, I didn't want to like cross wires, so there's like no real delta time. But it works. But we hit yield. So again, it's the same semantic where even with yield star, we will like next or schedule tick will run until it hits yield. There isn't really an exception to that rule. The difference is that now when we come back into this coroutine, so we hit yield, now we're back out in the tick, in the request animation frame. We take the schedule again, we're back in fade. Because we resume from the last yield we stopped at, which may be an arbitrary level of coroutines deep, right? But that was the last yield that was remembered. And that full call stack is preserved from frame to frame, or from tick to tick, and all the local variables are preserved. So in this case, this like t, this lerping value is completely local to the fade coroutine, right? And that gets computed locally. And then only once we're done with that do we come to rotate.
Yeah.
And then rotate.
I mean, I want to stop here for a sec for the sake of our 5 viewers. Hi everyone. This is the part that was the hardest for me to pick up when I first started doing coroutines. This is the part that throws everyone every time. We obviously don't know if y'all use coroutines. If you do, hell yeah, we love you. If not, this is the part that throws you. Is like you're gonna come back halfway through,
Yes.
right? But you can come back halfway through your sort of first function. But if that one had delegated, if it had done yield star, you're going to come back inside of that sub function. You're going to come back inside of that other one wherever that one left off until it's done, right? And so you can stack and stack and stack kind of as much as you want, and you can branch as much as you want and do all of that, and you're going to come back to wherever you left off, right? It's a little hard to like remember where left off means, like how that works, but once you kind of get your head in it, it's like hard to stop thinking that way.
Yeah. And I find the foothold that I find that stabilizes it is like, it's like a function call, right?
Yeah.
It's just across frames. But in the same way that like when I'm calling a function, when function A calls function B, function A is paused, quote unquote, at wherever it called function B. And when function B returns, function A resumes from that point, quote unquote. Delegating with coroutines is the same thing. You just kind of smear it across time. And this is an example of like compartmentalizing coroutines. So we use fade twice, right? We fade to 1 and then we fade to 0. And you can start to build up this like library, this like utility library of coroutines that you can like use kind of in an abstract way.
Yeah, totally. Sorry, I'm answering a couple people in chat who are like, this could be async await, and you're right, you can, but you were a little late. we discussed why Revsy chose generators for this one a little earlier. I think the summary is like
determinism.
It's determinism, right?
Yeah. And just there's also like the system makes a point to not give you, like I could have given you an animation loop, right? There's a reason that there actually used to be a schedule.loop function that would just do this automatically. But I actually think it's really important that you as a programmer see the main loop and have control over the main loop.
Yeah, this is an interesting choice that you made that's not made by almost any game system. And it's actually like when we jumped into our upcoming arcade game, this is one that like really threw me looking at your code. It's like, oh man, there's a whole like schedule logic in here, like that I have to get my head around.
Yeah.
Like up front, that's a little tricky. I haven't spent too much time in there. I kind of got enough of it because this is a game we're actually building, and so I'm like, I'm gonna get enough of this to get going on the thing I actually need to do. But like having to actually stop and think at the start how to build a schedule, like how do you want to schedule the sequence of things running, is non-trivial. And I think that actually might be like the hardest. Like the hard part to learning coroutines is like remembering that sort of like where you're coming back. The hard part to actually implementing them for me is actually all in the scheduler. It's like, how do you schedule? Why do you schedule? How do you all agree on like what the schedule means? Because like defining a schedule for your game is great till you have two developers. One of them knows how it works and one doesn't.
That's really interesting. Yeah. So yeah, I feel like, oh, that's so funny. Because
Unity cheated, right? Because they have that entity component system. And so like, yeah, there's an obvious, like, this is how it works in Unity. And because it's like, this is how it works in Unity.
I see what you mean.
Everybody agrees, everybody knows, right? Whereas if it's different, every project, like, it's a little harder. So like, I don't know. Yeah, I don't know where this is going other than like, maybe there's something to think about, like either convention or like clarity around like, how do you design a schedule might be like a question to answer.
Yeah, that's a really good point. I heard someone once say that the difference between a library and a framework is whether or not you have access to the main loop. And I very much want to make libraries. Like I don't want to make a framework. I don't want to tell you how to build your game. And if that means that you're doing more work, then that's a trade-off that I'm like, I actively want to make.
Yeah.
Because I only ever build systems with one schedule because and I build them in exactly one way where I tick once per frame. right? And so yield in that sense means wait one frame. Like that's what it means in all of my code. If you're building a system where it makes sense to have multiple schedules, sure. Like
Yeah.
that's completely expressible. I don't know what you're doing. I can't imagine why you would need that. But far be it from me to close that door on you, you know?
No, totally. And I think for Ajeeb, that makes a lot of sense. And I can even think of it one, which is like what I do a lot is I just like, there's already a schedule. It's called the event loop.
Yeah.
Like,
Yeah.
there's one in there. Don't do it. Don't do it again. If you're building something that's like short of a game, but north of a website, right? Like things like an interactive map that shows you like points on a map with videos playing and all that kind of stuff. It's like, yeah, you don't really want to be like spin locking, right? You don't want to be checking values every single frame.
Yeah.
You want to wait for an event, and when that event happens, you'll answer it. And in that case, it's like, well, that's like a whole different schedule. Technically, there's a lot of them because it's magic,
but they're all sort of paused in different places.
Yeah. And the other one that I've seen is Lua has this really interesting library called Lit that's like, we have libuv, the bottom end of nodes, like event loop is like, we have it. That's it. All your coroutines will wait on libuv. And that's it.
So this is again for simplicity, and I wouldn't even say determinism because you would get determinism out of what I'm about to describe, but mostly for simplicity. I designed the whole thing so that yield just waits one tick.
Yeah.
There are coroutine systems. There's an entire language called Cow. I think it's CEU.
Right. Yeah.
Super interesting language out of Brazil. From the like Lua, I think it's from PUC. I think it's from the same university that gave us Lua.
Is it really?
Yeah.
I love these
the best
manic
language nerds,
academics.
But that whole thing it's a coroutine language that's designed for embedded systems actually, and their coroutines wait on signals. So you don't say yield just in general. You say yield, and then you tell it like what signal you're waiting on, and maybe that signal is the next tick. Maybe that signal is a mouse event. Maybe that signal is network event, right? But only then will your coroutine be resumed. So there are definitely more sophisticated ways of doing things to make them wait on other signals, right?
Yeah.
By design, Ajeeb just waits on tick.
Yeah. When you're doing a game, I think waiting one tick is like the correct choice. But if you're doing something that's not a game but is a little too interactive, like that's where funny schedules come up. And so like maybe like a thing to add to the website is like a couple examples of how to do scheduling might be worth it. I don't know if you have them in there. Again, I will look at that beforehand.
Something I want to write in a sort of a companion to all this is I want to implement asteroids in Ajeeb, which I've already called. It's like the moment I thought of like the name asteroids, I'm like, okay, now I have to do it. My hands are tied.
No. Once you give Ramsey a multilingual pun, like you got him.
My hands are. I owe it to my people. But no, that's why I started calling Ajeeb a framework. Then it is kind of a library, but it's kind of a set of patterns, and it is a sort of a philosophy of like how I like to write games. And the library itself won't give you that philosophy, right? That's kind of like the library kind of enables a kind of philosophy, but the philosophy is these ideas, and there's definitely more work to do to sort of convey and communicate those ideas. But the nice thing about the yield means wait one frame is we can start to build things like this is example 6. So you get that nice little staggered fade. So they come in slowly and they all do a little spin and then they all kind of fade out. And the way we do that is all of the coroutines delegate to coro seconds. So you can wait physical time, right? This is something that's common enough that it's just built into Ajeeb, although it's easy to override. And this seems a little, in the weeds. It's like, oh, how are you waiting for like, you're not waiting one frame, you're waiting a total number of seconds. The way it's implemented, is extremely simple. We get the start time, and then while the current time minus the start time is less than the amount of time you want to wait, we wait 1 frame. There's no exceptions to this rule, right? And just being able to, like, it's the little gears in my brain are like quite simple. It's like the fact that it is a thing, and this is maybe because I did Lisp for 10 years, but it's like it's exactly one idea that is sort of like reconfigured. That is just like, makes me sleep a little easier at night. Seconds is really nice. This is like super helpful for like animations or like rhythm, right? And it's something that you'll like find yourself doing a lot of. I know at the museum gig, there were bugs in the art. Like some of the art was just wrong. And like there was an animation that came in about 4 seconds early, and all of it had been pre-rendered and baked down, and like we couldn't be changed. So we just wait 4 seconds in one of the stories just to like for the art to catch up, basically, and it's fine. So it's for like duct tapey stuff like that. The thing that I kind of want to get to is in the last 10ish minutes where this stuff starts to get really time flies when you're stretching time,
having fun with computers,
when you're stretching time across frames. The things that my computer science brain will call combinators, but you can build coroutines that take coroutines as input. And one of them is all. So Coro all will run every coroutine you give it at once. It's kind of like a mini schedule. It's not quite a schedule because you can't really add to it. But this line won't finish until all of its coroutines finish. So when we run this, we'll see that we start the race. We get this start race console log. And then we wait until all of these race car coroutines complete. And each one is a different colored car. So they start going, and we see that all of the evaluation is inside of the Y loop in race car, just increasing the Y. And they're all moving at different speeds just to make it kind of interesting. And we don't get this last end race until, so blue is done, red, black, and we're not going to get until the yellow one reaches, right? So you can write, like we're going to, in like multi-threaded code, this would be a thread join for any Java nerds out there. So like a coroutine is going to run all of these like sub coroutines basically in its place. Only once they're all finished will it sort of move on. This gets used, you can sort of build in our snake game, like the snake is itself a bunch of coroutines, and the actual snake is just this all. That it's the coroutine for the eyes, the coroutine for the body, the coroutine for so that's kind of like a, there's a version of this in async await in the JavaScript library, promises.all is kind of similar.
I've used that one a lot, actually.
It's super important. Where things get really, this was like a moment of revelation. First is really powerful and really different. This is similar to all, but when the first sub coroutine completes, then the whole thing completes. So if we run this, boop,
I think there's something similar in promises.any. I think there's a similar API.
Oh, does promises.any return?
I believe it's as soon as any one of them's done.
I would, and I would assume that it gives you the value of the first one that completed, because that's what
I believe that is the case, but I haven't used it in a while. But
so here, it's the same as the last example. The difference being we give each race car a label or like an ID, and whichever one finishes first, so here in this case, the black car, returns its value, which gets stored in the variable winner.
Oh, it's very clever.
So this is something you cannot do in Unity coroutines. You cannot return values because of the way it's built on an older feature of C# that just doesn't support it. And this is where things start to get architectural, where you can start to build logic that runs over time and produces values that it computes over time, and then those values are used in other coroutines to sort of sculpt the march of the system. So in the game that we're building for Arcade Commons, this is like when a snake dies, we're building like a snake game, and when one of the snake dies, it returns itself, and it basically reports its name. And the main game coroutine sees like, oh, player 1 or player 2 died, and we're able to sort of display that to the player. So really, really powerful. It's usable. I'll jump ahead before we get to try finally, because try finally is pretty trippy. You can use first to start doing interesting semantic tricks where I can actually connect a coroutine that is infinite and is like really natural to write as an infinite loop, and a coroutine that is finite. And if I combine them by first, now I have something that is finite, right? So here, this is an example of a card spinning until I click on it.
Oh, that's clever. That's a clever one.
And the way that looks is you just write spin with the natural logic of I'm just spinning. I don't have a care in the world other than like increasing the rotation property on this object. And similarly, clicked, I don't have a care in the world except for waiting until I get clicked. And when you combine them, you get something that is like aborted by clicking. If you want to expand the logic to say, okay, wait until you're clicked, or half a second. Now it'll wait until a click or half a second. So you can have your like termination logic and your like core logic abstracted out, and they don't cross wires.
That's really clever. That's a thing I actually haven't done. That had not occurred to me in all my time of using coroutines to do it that way. That's clever.
So the thing that this pairs with that you cannot do, most systems make this quite difficult to do. In JavaScript, it just sings. You very often in video games want cleanup logic. Like what I'll want, like this is fine, but I might want to fade everything out once we're done, right? Coroutine or generators in JavaScript respect try finally. So if a coroutine is canceled, so basically when a coroutine finishes in first, everything else that didn't finish is canceled prematurely. And if you're canceled while you're waiting on a yield, your finally code will run.
Yeah.
So
that's great. And that's actually good because even like compared to something like async waits, like you have to do that awkward catch thing. Like it's a little goofy.
So now we have a coroutine where things run to the end, and they're guaranteed to schedule this fade out logic. And if we want to start doing things like, okay, what if we want to fade out everyone but the winner, right? I can write local logic that says something to the effect of so this line will only run for the winner, right? And now I could say, if I'm not the winner, fade me out. Super, super straightforward intervention with local variables that isn't going to affect anything else. And you get something that when the cleanup logic reacts to the actual semantics of your system, right? And we flip this and we get the opposite, right? Where it's just that it fades out.
Yeah, the try finally thing is really cool, and that's not anywhere else. No. My beloved Lua coroutines don't have that one.
I've looked. You can.
I'm sure you could contrive. I'm sure you could make it work.
It's like a crisis of conscience for me because try catch finally, like what you have to do in a language to support that is so gross, and it shouldn't be in languages.
And it feels gross to write it. Like I hate writing try catch stuff. It's gross.
This does it.
But this one thing it does is very good. We have a couple comments in the chat. Jeremy Sachs is clarifying that promises.any and promises.race are similar to first. The details apparently comes into like that a promise can fail. A concept that is not totally relevant in generators. And then Joe, who I know from Mastodon, hello, is like feels a little over her head, but is like it seems more intuitive than like await async stuff, which
Great.
love to hear it. Come over to the dark side. As for like like when I was learning coroutines, it was really hard. It's really confusing, and like I've been a dorky computer programmer since I was 12, and it's still, this was one of the like figuring out coroutines the first time was one of the like moments where I'm like, whoa, this is a computer thing I really like. It's not that I don't have the context. It's not that I don't have the like information. It's not that I need to go read the docs. It's like, no, I actually conceptually need to change how I'm thinking. I actually have to understand this like at a high level.
Yeah. And my sense of it, and to your earlier point about like, oh, thinking about the schedule is like a challenge, and it absolutely is. And what I like about this approach is it makes really explicit what makes this kind of like work hard, which is unlike most kinds of programming, if you're building games or interactive systems, you have to think about time, and time is just hard, right? Like there isn't, like when I write a compiler, I'm not thinking about time. Like I'm just doing transformations, and like time is effectively static, right?
Yeah, it doesn't matter. And even when you're doing something a little bit interactive, like a web server or something, it's like you're intentionally just like abstracting time out. You don't want to think about time. You want to think about events, and you know they happen across time and etc. But like you're not like writing your like node server or whatever, like thinking about time in the way that you're thinking about time in a video game or in an interactive installation or anything like that.
Yeah, and then the flip side of that, the update loop as a core like semantic is like not enough, right? Like I need more than just staring at time through a keyhole of like, oh, a 60th of a second has passed, run some code from scratch, right? So the coroutines kind of sit in the middle where it's like I can pause and resume on frame boundaries, but I get to keep my like call stack, I get to keep my like local state, and I can start building almost like tree-shaped systems where I have like things that call things that call things, and they sort of return to each other and then call other things.
Yeah,
and I love it. And I hope that was interesting. You all have the link. Play around with the other examples. There's this is a reproduction of like one of the animation like bits of animation logic in the Snake game with like a little guy that looks around. And I will eventually like launch like a little coroutine platform where people can sort of share and like throw on coroutines.
Yeah, absolutely. Yeah, that link for the tool that you've been showing is scrolled up in the chat. The link for Ajeeb.games, I'll type it in there right now, but it's also in the description for the video. If you want to actually use this in production, you'll be our hero. We love it with like, hell yeah. We're using it in production, no fear.
I've been using it for 5 years. It has
100% forever
code coverage. It's got a very robust test suite. Like it's not
suite. I've never written a test suite in my life.
I've written two, one for my Clojure compiler and one for this. This one is very thorough.
One would hope that the Clojure compiler got a test suite.
Yeah, I guess I didn't write the Clojure test suite. I passed it after 9 years, but but yeah, no, I feel having used it in production, I feel comfortable saying like, yeah, you can use this in production. It's fast and robust and well tested.
Yeah, it's pretty much as good as
I know how to make
it. It's going to be. I would say I trust it more than I would trust most JavaScript libraries, if for no other reason that it's a lot smaller and I can go read it.
You can read it on the subway. Yeah, there's not a whole lot going. Even the implementation of first, which is interesting and tricky. Like this is it. It's not.
Yeah, it's not too complicated.
You can sort of wrap your head around it.
Yeah, I would actually. Yeah, maybe a future Skillshare. I feel like we always reach the end of these and we're like, what's the next one gonna be? I don't know if I've shown it to you. I don't know if I've shown you Lit or WebLit, the
You've
Lua.
told me about it. I've told
you about it. It's really impressive, and it uses every feature in Lua's coroutines, even the like crazy stack list stuff. For people who are tuning in, it seems like y'all are a little less drinking the coroutine Kool-Aid than we are. But there's like a distinction about whether making a regular function call, like how does that interact with the coroutine? Lua makes a different decision than JavaScript, and almost anybody else does. But because of the way it does it, someone has like built this like weird little like coroutine based library for Lua that does like async await style server code with no keywords. You don't think about it. You just say like, wait for the next, it's just like, hey, get a request. And when a request appears, your thing will get called and you are not spin locking. You're not doing anything, like cycles are not being wasted, and you're like as efficient as libuv will let you be.
Because that all is just you're basically writing synchronous code or code that looks synchronous.
You're writing code that looks almost completely synchronous, and it is secretly asynchronous in a way that's like bizarre. Like when you first see it, you're like, what is happening? How is that happening? But then the minute it clicks, it's like, oh, I don't have to even worry about this. This is like solved, right? It's like the async is done. And it does it basically by like using Lua lets you find out, like it lets you just get a reference to the coroutine you're inside of from inside the coroutine. So what happens is like basically I'll cheat. I'll give you a preview for anybody still watching. It just says like, hey, give me the reference to the coroutine I'm in. Stick that in the callback for the libuv event, and then yield.
Oh wow!
And it just yields, and then when the and then it will automatically like when libuv comes back around, it fires up the coroutine. You come right back. It yields. It pops back from the call stack from wherever you were. Everything's done.
So wild.
It's genius. That's like
really wild.
Unbelievably genius. You don't even have to think about the .next. You don't have to think about like wrapping your coroutines. You're literally like,
oh, there's not even a top level like wrapper for the coroutines. You just kind of like
no, because there's one in the library, right? Like if you're saying like, hey, I'm writing a thing that's waiting on HTTP requests.
That's right? And then basically everything down.
Coroutine in the library. Your code is a function.
Yeah.
And then you're using the library to like await for input or whatever. It does the coroutine math on the back, and then you come back in and you just don't even see it. And if you wanted to write a new thing, which I've done a couple times, like you just like stick a thing on a callback for libuv and it's done.
That's something you get. Something that's really interesting about Lua is like the VM is fair game. Like you can ask really deep, dark questions. In JavaScript by design, because it's a heterogeneous implementation ecosystem. Even if you like ask like, oh, what's in .next? It's like you are not entitled to that information.
You're asking the wrong questions.
Nope. You can
whatever you're doing, stop.
You can invoke it. That's all you're getting. Black box. Yeah. And what you get
libuv is the real opposite. It's like libuv is very much built by implementers. And it's like, oh yeah, no questions, like no nonsense. Like this is thing that responds to events. It does async IO, and it's super clean. It's one of the best documented libraries I've ever seen, actually. Like it's crazy that I can, without having even touched the C library itself, I could confidently use the Lua wrapper for it.
Crazy, yeah.
And like so confidently that like I could pull up the libuv documentation and read that, and that would tell me how to work the Lua one, right? Which speaks to both of those projects. Like the Lua wrapper is really, really good. But also the C library being that clean that a like scripting language binding is perfect. Like that's no one does that. Come on.
Yeah, no, that's where everyone dies at that.
Yeah, no, like the minute you need a binding from a C to a scripting language, like you're done. You're totally done.
And with Lua, I've had in Renoise, I had problems with some generator stuff where you can't resume a coroutine across a C call boundary. There's like some limitations.
Yeah,
and
that's a hard limit.
Yeah. Because it's doing weird set jump magic, and
I don't understand it. I'm one of the Lua people who doesn't touch the C side too much.
I've never.
But yeah,
I've read purrs, and I've read Mike Paul, who has been described as
the robot from the future himself.
the robot from the future. Yeah, the who I wonder. Yeah, sometimes I wonder. I look off into the night sky. I'm like, where is Mike Paul today? Like, what is he? What programming language is he sort of going to optimize?
Yeah.
I've read his stuff, but yeah, no, I've never messed with the. I mean, although Ivan does a lot. I get a lot of like Lua integration stories from Ivan.
He swore off Lua, I thought,
but he came back to it for not. He swore off Lua for like. I mean, I disagree with him, but he swore off dynamic languages for core game code because Ivan's philosophy is like just use C++. Like, okay, Ivan.
Well,
if only we were all Ivan. But he uses it for. I know he's working on a card game where the actual the rules of each card are just Lua files.
Oh, that's a clever use for Lua. That's exactly what it's for. No one wants to write pointers inside of their game logic.
No,
it's not fun.
No, thank you. But yeah, this is
Ajeeb and Coroutine demos. Thanks everybody for tuning in. I think we've lost our audience, but that's great. They were here for the instructional part, which thank you all for tuning in.
Yeah.
And cool. Yeah, we'll be back in a couple of months hopefully to do another Skillshare. Maybe it'll be Andy, maybe it'll be me. We'll see.
Yeah.
But yeah, I'm gonna turn off the go live on YouTube. Bye everyone, and stream. Okay. All right, we're actually off now.
Woo!
Woo!